Welcome to Manifested Publishers.
Hello learners, welcome to our today's lesson, which we are learning about empirical and molecular formulas. Empirical and molecular formulas. Before we get into this lesson, I want to remind you a little bit of what we were doing in the previous lesson. In the previous lesson, we were discussing the relationship between the relative molecular mass and the moles, or the relative formula mass and the moles, where we did some examples and said, for example, if you have, let's say, sodium sulfate, that the relative formula mass is given by the sum of the relative atomic masses of all the atoms in the unit formula of that compound. And therefore, the relative formula mass, we got it by adding the masses or summing up the masses of all the atoms forming the formula sodium sulfate. And therefore, the masses were, in this one, sodium has a mass of 23, but there are 2 atoms of sodium, therefore it's 23 times 2. You add the mass of sulfur, which is 32, and you add the mass of oxygen, which is 16, but because there are 4 atoms, then you multiply by 4. Therefore, this is 46. You add 32, then you add 64. This will give you, that is 46 plus 32 plus 64. That is giving you 142. Therefore, the RFM is 142. That is the RFM of sodium sulfate, which is the relative formula mass of sodium sulfate. And therefore, we said that 1 mole of sodium sulfate is just equivalent to mass of 142. That is what we were doing in the previous lesson. Again, we said that you make sure that you can be able to calculate the relative formula masses of various compounds when you are given the relative atomic masses of each of the elements forming those compounds. That is what we were doing in the previous lesson. And I hope that you still remember that, and you are going to do more examples so that you get better understanding of that relationship between the relative molecular mass, relative formula mass, and the number of moles. Therefore, in this lesson, I want us now to concentrate on the empirical and molecular formula. But in this lesson, we are going to focus on empirical formula, and then later we are going to learn about the molecular formula. Therefore, we start with the empirical formula. I'll start by defining empirical formula and say that it is a formula that gives the simplest whole number ratio of atoms in a compound. It is a formula that gives the simplest whole number ratio of atoms in a compound. It is a formula that gives the simplest whole number ratio of atoms in a compound. That is what empirical formula is. That formula which gives the simplest whole number ratio of atoms in a compound. That is what is referred to as the empirical formula. And then again, remember, we are talking about whole number ratio, not decimal places, but whole number ratio of atoms which are forming a certain compound. I want us to do examples of empirical formulas. I'll give the first example. First, that is the first example I want us to do. An oxide of silicon was found to contain 47% by mass silicon. What is the empirical formula of the oxide of silicon? Therefore, this is how we go about this. So here we have two elements. We have silicon and we have oxygen. Because the oxide of silicon, therefore the silicon is combining with oxygen to form the oxide. The composition percentage or percent composition of silicon, you're told that an oxide of silicon was found to contain 47% by mass. Therefore, the mass of, or the percentage composition of silicon in that oxide is 47. So silicon is 47%. Then what is now the percentage of oxygen? The percentage of oxygen will be 100, which is now 100%. Then you subtract the percentage of silicon, which is 47. And this gives you 53. 100 minus 47 is 53. And therefore, the percentage of silicon is 47. The percentage of oxygen is 53. Then you now have the relative atomic mass. The relative atomic mass of silicon is 28. The relative atomic mass of oxygen is 16. And therefore, this percentage you now divide by the relative atomic masses. Silicon is 47, you divide by 28. Then oxygen is 53, you divide this by 16. When you divide, then you are now going to get the ratio. Therefore, when you divide 47, divide by 28, this is giving you 1.6, 1.6786. You give at least 4 decimal places. Then for the oxygen is 53 divided by 16, which is 3.3. 3.3125. That is the percentage of the ratio. That is now the ratio in which silicon and oxygen are combining. Once you get now those ratios, then you now divide by the smallest. Divide by the smallest. Then when you divide by the smallest, then the smallest between these two is 1.6786. Therefore, this is divided by 1.6786 divided by 1.6786. Therefore, this will give you 1, and that will give you giving you 1.9733. 1.9733. And therefore, then this one you now have to round it off. And therefore, silicon and oxygen have 1.9733. Then this one now we round it off to the nearest whole number, and therefore this will be 1 and this will be 2. This is now the simplest whole number ratio. It is the simplest whole number ratio, that 1 is to 2, and therefore the empirical formula of oxide of silicon is, there is silicon, so one atom of silicon, 2 atoms of oxygen. That is how you are now getting the empirical formula, and this is now the empirical formula of silicon oxide. That is the empirical formula of silicon oxide. That is how simple the questions or calculating the empirical formula is. You have the question, you now get the composition by the percent composition, that for silicon is 47, the oxygen is now 100 minus the percentage of silicon, then you get that as 43. Then after getting the percentage, you divide by the relative atomic masses. Once you divide with the relative atomic masses, the silicon is 28, the oxygen is 16. Then when you divide by 28, you're getting 1.6786. Then this is 3.3125. Then once you now get those ratios, they now divide by the smallest. And the smallest between the two, this is 1.6786. This is 3.125. This one is larger than this, and therefore the smallest is this. They will divide now on both sides by the smallest, divide by 1.6786, divide by 1.6786. And once you divide, then this you get as 1, then this is 1.9733. And therefore, when this is 1.9, you have just said that you just round it off to the nearest whole number. It is 1.9, and therefore the whole number is 2. And therefore, 1, 1, and 2, that is now the simplest whole numbers. The simplest whole numbers. Remember, in empirical formula, we are saying that it's a formula that gives the simplest whole number ratio. Therefore, they must be whole numbers. The simplest whole number ratio of atoms in a compound. And that's now how we have come up with this formula of silicon oxide. Therefore, this is the empirical formula of silicon oxide. The second example, That is the second example. The percentage composition by mass of an oxide of iron is 70% iron and 30% oxygen. Then determine the empirical formula. The empirical formula, which you are going to have, then in this case you are having iron and oxygen combining. We now get the percentage composition first. Percent composition. Iron, the percentage 70. The percentage of oxygen is 30. So 70 and 30 makes 100. The next, we are dividing by the relative atomic mass. So we have the elements combining, then iron and oxygen. Percent composition. Iron is 70 and oxygen is 30. So the percentage of iron is 70, oxygen is 30. Then we now divide by the relative atomic mass. Divide 70 by relative atomic mass of iron is 56. The RAM of oxygen is 16. Therefore, we are dividing iron by 56 and oxygen by 16. This is now going to give you, or to give us the ratio in which the two are combining. And 70 divided by 56 gives us 1.25. And oxygen, that is 30, divided by 16, that is 1.875. Then once you get those, then you say that to divide by the smallest among the two. We have 1.25 and we have 1.875. Therefore, the smallest is 1.25. Therefore, on both sides, 1.25, 1.25. This now definitely will give you 1, and this is divided by 1.875 divided by 1.25. You'll get it as 1.5. Anytime you get 1.5, then this is, you'll have now to multiply by 2 to make it a whole number. Multiply by 2 to make it a whole number. And then by multiplying by 2, you're now multiplying both sides by 2. Therefore, this is multiply by 2. You multiply by 2. 1 times 2 is 2. 1.5 times 2 is 3. And therefore, this is the simplest whole number ratio. The simplest whole number ratio in which they combine. And therefore, the empirical formula is iron, there are 2 atoms, then oxygen, there are 3 atoms. That's now the empirical formula of iron oxide. That is the empirical formula of iron oxide, or iron 3 oxide. Now, if you look at what we got here and what you have gotten at that point, this was 1 and this was 1.95. Okay, 1.9733. This one we have rounded it off to the nearest whole number. We've rounded it off to the nearest whole number. This was 1.5. Then we have multiplied by 2 to make it a whole number. Therefore, when you multiply by 2, you now multiply both sides. Therefore, anytime you get a 0.5, you get a 1.5, you get a 2.5, you get a 3.5. These ones, you always multiply by 2 to make them whole numbers. That is now when you get 0.5, you get 1.5, you get 2.5, you get 3.5. Now in the ratios at this point, not anywhere else, at this point, then to make them whole numbers. So a 0.5, you multiply by 2, both sides, or if there are 3 sides then, or both sides, yes, both sides. But when you get a 1.9 or a 1.8, that one, you are rounding it off to the nearest whole number. If you get a 2.9, then you round it off to the nearest whole number, which is 3. If you get 3.7, you multiply it the nearest, you round it off the nearest whole number, and you'll get it as 4. Therefore, that is that is the second example we have done. I want to give you the third example before I give you some questions to calculate on your own. So number 3. That is the third example, which reads, a compound containing iron and chlorine gas was analyzed and found to contain 2.8 grams of iron and 3.55 grams chlorine. Calculate the empirical formula of the compound. Then the relative atomic mass of iron is 56. The relative atomic mass of chlorine is 35.5. Therefore, the elements combining are iron and chlorine. This one we don't have the percentage composition, but you have the mass. The mass of iron is 2.8. The mass of chlorine is 3.55. Then the relative atomic mass, you now divide the mass by the relative atomic mass. The relative atomic mass of iron is 56. The relative atomic mass of chlorine is 35.5. Therefore, when you divide, you'll now get the ratio in which they are combining. First is 2.8 divided by 56. This is giving you 0.05. And 3.55 divided by 35 is giving you 3.55 divided by 35.5. This gives you 0.1. Then once you reach that level, you don't divide by the smallest among the two. The smallest is 0.05, therefore 0.05, then 0.05. This will get it as 1. 0.1 divided by 0.05 will get it as 2. And therefore, this is the simplest whole number ratio. The simplest whole number ratio is 1:2. And therefore, the empirical formula is like this. It's 1 atom of iron, 2 atoms of chlorine. That is how you're supposed to go about those questions. Therefore, just know in mind that you are calculating, or you want to come up with the simplest whole number ratio in which the atoms of elements are combining in a compound. And that is how simple calculating the empirical formula can be. I want to leave you with these questions for the assignment. Several questions you calculate on your own. Well, that is the assignment. There are 5 questions. The first question is, in an experiment, it was found that 6.09 grams of lead combined with 0.95 grams of oxygen. Calculate the empirical formula of lead oxide. The relative atomic mass of lead is 207, while oxygen is 16. The second question, the compound weighing 42 grams was found to contain 12 grams magnesium, 6 grams carbon, and the rest oxygen. Determine the empirical formula of the compound. Relative atomic mass of magnesium is 24. The relative atomic mass of carbon is 16, and that of oxygen is 16. Question number 3. A sample of a hydrocarbon of mass 51.2 grams was analyzed and found to contain 12.8 grams hydrogen. If the formula of hydrocarbon is CXHY, that is carbon, then HY, hydrogen, then find the values of X and Y. Then the relative atomic mass of carbon is 12.0, then that of hydrogen is 1.0. Question number 4. The empirical formula of an organic compound is C1H2O1. Then if the empirical formula mass of the compound is 30, then find the percentage composition of the elements in the compound. Then RAM of carbon is 12.0, hydrogen is 1.0, and oxygen 16.0. And the last question is, in an experiment, 3.1 grams of a compound of carbon, hydrogen, and oxygen produced 4.4 grams of carbon dioxide and 2.7 grams of water on complete combustion. Then determine the empirical formula of the compound. Then relative atomic mass of carbon is 12.0, oxygen is 16.0, and hydrogen is 1.0. Therefore, ensure that you've done those questions before we meet in the next lesson. In the next lesson, I will try and guide you through some of them. Then I give you some more questions. Therefore, do the questions. We meet in the next lesson. We do some of them and give you some more examples so that you have some more a deeper understanding of how to calculate the empirical formulas. See you in the next lesson. Thank you.